Good morning dear students. In this video we will discuss about chemical bonding and molecular structure chapter. So here I am going to give a few important topics in which way the questions will be asked for objective purpose. Okay. For objective need not to read the complete chapter. It's enough to know what the topics, whatever the questions will be asked. In that the most important and the first topic is Lewis dot structure. In this Lewis dot structure, first we want to know how to write Lewis dot structure. So they will give a question, write a Lewis dot structure, a find Lewis dot structure for the given molecule. Okay, so that you have to be ready to draw Lewis dot structure or finding of a Lewis dot structure for a molecule. So for that you need to follow 5 important points. Okay, in that the first point is count all the valence electrons first. So whatever the valence electrons are nothing but the electrons present in the outermost shell. That is called valence electrons. So first of all, count all the valence electrons present in a molecule. Next, second point. Draw least electronegative atom at the center. Okay, so if many atoms are present, if you take a molecule, it may contain 2 or more atoms. In that, whatever the atom is having more electronegativity, least electronegativity. So that least electronegative atom should be taken as the center atom. Okay, least electron atom is considered as the center atom, and the remaining atoms spaced around it. Whatever the remaining atoms are present, that evenly spaced around it. We have to arrange the remaining atoms around the central atom. That is the second step. And the third step, draw single bonds to the central atom. After writing or placing the central atom and the surrounded atoms, then you have to keep a single bond between the central atom and the surrounded atom. Next, fourth one. Complete octet with the remaining electrons for the outer atoms. Okay, so first you have to arrange central atom, then outer atoms. After that, put a bond between the central atom and the outer atom. So then arrange the remaining electrons on the surrounded atoms by reaching its octet configuration. What is meant by octet configuration? So octet is nothing but having 8 electrons in its outermost shell. Having 8 electrons in its outermost shell. That is called octet configuration. Okay, clear? We need to satisfy octet configuration by placing remaining electrons on the surrounded atoms. That is the fourth one. Okay, and if any and added remaining electrons to the central atom. If any extra electrons are there, so then the remaining electrons should be added to the central atom. Next, last point, fifth point. Complete the central atom octet by making covalent bond. Okay, here for in the above fourth point, octet configuration of remaining atoms we have done. And for this fifth point, it related to the central atom. So for that central atom, we have to balance its octet by making covalent bonds. That is about the 5 important points what you want to keep in mind while drawing Lewis dot structure for any molecule. So first count the valence electrons, then select a central atom which is in least electronegative, then draw a single bond with the central atom and the surrounded atoms. Fourth point, complete the octet configuration according to sharing the electrons present in valence shell. So fifth and final point, complete the octet configuration even for the central atom. That is about the 5 important rules what we want to follow. So first we will see examples related to this Lewis dot structure based on the above 5 points. First one, drawing of nitrate structure. Nitrate ion is a molecule or ion. For this we want to draw the structure. So first point, what? Count all the valence electrons. All the valence electrons in the sense valence electron related to all the atoms present in that molecule. So in that the first atom is nitrogen. Nitrogen belongs to 5th group and its valence electrons are 5. That's why I have kept here 5. And next atom, oxygen. Each oxygen atom belongs to 6th group or 16th group. Okay, so that oxygen containing 6 electrons in the valence shell. Okay, total number of oxygens present here are 3. Then 6 into 3 we want to write. 6 into 3 plus 1 I have added. Why I have added here 1? Because if a molecule or ion is having negative charge, then add 1. If 2 negative charges are there, add 2. If 3 negative charges are there, add 3. If 1 positive charge is there, subtract 1, that is minus 1 we will write. If 2 positive charges are there, minus 2 we will write. Positive, if positive is there, subtract that number. If negative is there, add that number. So minus indicates minus 1. So that we have to add here 1 extra electron. Remember, it's very easy. Don't confuse. First of all, you want to count the valence electrons present in each and every atom of a molecule. So here 2 atoms are there. One is nitrogen, other one is oxygen. Only one nitrogen is there. That valence electrons are 5. And oxygens totally 3 are there. Each oxygen containing 6 electrons in the valence shell. Each oxygen contains 6 electrons in the valence shell. So that we want to write 6 into 3 because 3 oxygens are there. And having minus 1 charge, 1 negative charge is there. That's why we want to add plus 1 to that. Okay, then 5 plus 18 plus 1. So 6 3s are 18. 5 plus 18 plus 1. Total number of valence electrons are 24. By adding all this, you will get 24 electrons. Now the first step is complete. Now second step, draw the least electronegative atom as the central atom. Here only 2 atoms are there, that is nitrogen and oxygen. Among these 2, oxygen is more electronegative and nitrogen is least electronegative. Take that nitrogen as the central atom. Least electronegative atom, we have to take it as the central atom. And next, draw the remaining atoms around spaced around it. Okay, remaining atoms are nothing but 3 oxygens. We will write these 3 oxygens around the central atom like this. That is second step. Next, the third step, draw single bonds to the central atom. Okay, this is central atom. So to the central atom, I have drawn here single bond. That is the third step. Next, move on to the fourth step. What is fourth step? Complete octet with the remaining electrons of the outer atom first and add the remaining electrons to the central atom. So first here you can see. So in this bond, 1, 2, 3, 4, 5, 6. 6 electrons already we have drawn. Okay. Still how many electrons are there? 26 minus 6 is 18 electrons. So that 18 electrons are the remaining electrons. In the fourth step, we want to add these 18 electrons to the outer atoms. Okay, by balancing its octet configuration. Even we want to balance the octet configuration of outer atoms. Fourth one. So on this oxygen, you can observe only 2 electrons are there. To reach octet configuration, still it requires 6 more electrons. So that I have kept here 1, 2, 3, 4, 5, 6 electrons. Even here you can observe on this oxygen only 2. On this oxygen only 2 electrons are there. Still it requires 6 more electrons. That's why in this 18 electrons, 6 more electrons I have written on this. 1, 2, 3, 4, 5, 6 and 7, 8. Its octet configuration is balanced. In the same manner for the third oxygen also. Third oxygen is also containing only 2 electrons. Still 6 electrons we have to put to balance its octet configuration. 1, 2, 3, 4, 5, 6, 7, 8. Now for all the outer atoms are nothing but oxygen atoms, octet configuration is balanced. Okay, then total number of electrons you can count now. 1, 2, it should be equals to the total number of valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so total number of electrons here what we have written are 24, which is equals to its valence electrons. It is balanced. Understand? Now the last one, complete the central atom octet configuration by making covalent bond. So on the central atom, this is central atom, total number of electrons present are 1, 2, 3, 4, 5, 6. Only 6 are there. To reach octet configuration, still it requires 2 more electrons. So any one atom can donate this lone pair of electron to make a covalent bond. If these 2 electrons are donated and make a covalent bond here, or these two electrons, any one pair of electrons involved, then we will get a covalent bond, that is double bond is formed. Then the oxygen will be having only 4 electrons. 4 plus 4, again it is balanced by octet configuration. Even nitrogen octet configuration is balanced because it has totally 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen octet configuration is balanced as well as oxygen's octet configuration is balanced. Then this we can take it as the final structure of NO3 minus. So that you can write minus, one negative charge is there, so that negative charge we can put here. So this is about the NO3 minus ion molecular structure. Okay, like this we can write about the Lewis dot structure for any molecule. Now we will take one more example. So now we can see for the second one, that is NO2 minus ion. So for NO2 minus ion, we will see how to draw Lewis dot structure. So first step, we want to count the total number of valence electrons. Here nitrogen is there. Nitrogen valence electrons, just now I have told you, that is 5. And each oxygen valence electrons are 6. Totally 2 are there. Then you can write 6 into 2 or 6 plus 6. Okay, and plus 1 I have added. You know why I have added this plus 1? That is due to having one negative charge. If one negative charge is there, add 1 electron. 2 negative charges, add 2 electrons. If 1 positive, remove 1 electron. If 2 positive, remove 2 electrons. Here 1 negative charge, I have added plus 1 charge. Then the total number of electrons here are 6 plus 6, 12, 12 plus 5, 17, 17 plus 1, 18 electrons. Okay, then what do you want to do? So select the second step is select the central atom, which is least, that has to be selected as the central atom. And you can see among nitrogen and oxygen, the least electronegative atom is nitrogen. So I have taken that as the central atom. And the other 2 atoms are surrounded on it. Other 2 atoms I have written like this. And the third point is that make a single bond between the nitrogen and other atom. Between nitrogen and other atom, I have made a single bond. Then the fourth bond is the remaining electrons we have to keep on the oxygen atoms to balance its octet configuration. Okay, so the other atoms are nothing but here oxygens. On oxygen, I am writing the remaining 8 electrons. See, 1, 2, 3, 4 electrons we have written. 18 minus 4 is 14 electrons. All the 14 electrons we cannot put on oxygen because on oxygen already 2 electrons are present. 1, 2. So to reach its octet configuration, how many electrons still it requires? Only 6. So 6 electrons have written here. On this oxygen also 2 electrons are there here. And the remaining electrons required to reach the octet configuration is 6. So that 6 electrons also I have written here. So 6 plus 2, 8 electrons. 6 plus 2, 8 electrons. 14 minus 6 plus 6. What is 6 plus 6? 12. 14 minus 12 is 2 electrons. Still 2 more electrons are left. Right? 14 electrons are left. In that 14, 12 we have arranged on the 2 oxygen atom. So then still 2 more electrons are left. These 2 electrons we will keep on the nitrogen atom as a lone pair. Okay, now you can see the octet configuration of outer atoms are balanced but not on the central atom. So to balance the octet configuration on the central atom, we need to make another covalent bond. So either this pair of electrons on oxygen or this pair of electrons on oxygen will make a double bond with the nitrogen. If this lone pair of electrons involved in making a double bond, then we will get this structure. Now you can see around nitrogen 1, 2, 3, 4, 5, 6, 7, 8 electrons. That means it reached its octet configuration. As well as other atoms also reached its octet configuration. Finally, this we have to consider as a Lewis dot structure, and NO2 is having a negative charge, so completely put a square brackets and negative charge. That's it about the Lewis dot structures. So to write Lewis dot structure of any molecule, first you want to remember the 5 points. So count the total number of valence electrons present in it. Then second one, select the central atom which is having least electronegative. Third one, arrange the other atoms around the central atom. Third point is that make a single bond between the central atom and the surrounded atoms. Fourth one, share the remaining electrons on the outer atoms to reach its electronic configuration. If any electrons are left, after sharing electrons, if any electrons are left, that you can put on the central atom. Understand? And finally, fifth point, balance the octet configuration of central atom by making a covalent bond. These 5 points you want to remember to draw Lewis dot structure. Now, we'll move on to the next important topic, that is formal charge. So, formal charge is also said to be one of the most important topic which is related to this chapter. So, first we want to know what is the definition of this formal charge. Formal charge is the charge assigned to an atom in a molecule. If you take a molecule, many atoms will be present. Okay, now this is the charge which is assigned to the atom, particular atom present in a molecule, and that particular charge is called formal charge. Okay, we can call that charge as formal charge. That formal charge is always calculated by using a formula. Formal charge is always equals to number of valence electrons minus number of dots minus number of lines. Okay, so by using this formula we can easily find the formal charge of a molecule. So formal charge is nothing but the charge which is assigned on an atom in a molecule, that is called the formal charge. So that formal charge of a particular atom in a molecule can be calculated by using this formula. Formal charge equals to number of valence electrons minus number of dots minus number of lines. So we'll see, we'll take one example, that is I am taking here ozone, O3 as an example. Okay, remember dots are nothing but lone pair of electrons. Lone pair electrons. Number of lines is nothing but bonds present around it. That's it. Okay, clear? Now we'll calculate formal charge for the oxygen atoms present in the ozone. So this is Lewis dot structure of ozone, that is O3 molecule. Okay, so 3 oxygens are there. These 2 oxygens are bound by double bond and these 2 oxygens are bound by single bond. Now take or consider this as first atom, this as second atom, this as third atom. That is your wish. You may also take this as first, second, third, or first, second, third. That is your wish. Now I have to consider the oxygen, this oxygen as the first one. Now we need to find out the formal charge for this first oxygen. Okay, so then formal charge on first oxygen is equals to number of valence electrons. We know the valence electrons on oxygen. Oxygen atomic number is 8. Its configuration 1s2, 2s2, 2p4. Okay, this becomes the valence shell. So valence shell is having how many electrons? 4 plus 2, 6. So the total number of valence electrons are 6 on oxygen, that I have taken here. What is next? Minus number of dots. Dots are nothing but lone pair electrons on first oxygen. How many dots I have represented? 2, right? 2. Minus number of lines. On first oxygen, how many lines I have written? First line, second line, third line, totally 3. That's it. Okay, 6 minus 5, which is equals to plus 1. Formal charge on the first oxygen is plus 1. Next, for second oxygen. So this is second oxygen. On second oxygen, we need to find out about its formal charge. That is equals to number of valence electrons. We know valence electrons in oxygen, that is 6, minus, next, what is number of dots? On second oxygen, 1, 2, 3, 4 dots are there. Minus number of lines. On the second oxygen, the total number of lines I have written here only 2. Okay, so 6 minus 4, 2, plus 2 minus 2 get cancelled, and finally its formal charge is 0. For the second oxygen, the formal charge is 0. Next we will see for the third oxygen. Okay, this is the third one. For third oxygen, we want to find out the formal charge by using the same formula. Then formal charge on third oxygen is equals to number of valence electrons. Total number of valence electrons are 6 minus number of dots. On this third oxygen, number of dots are 1, 2, 3, 4, 5, 6. Minus number of lines. Only one line is there, we will write 1. Minus 6 plus 6 get cancelled, then the formal charge is minus 1. Okay, minus 1 is the formal charge on the third oxygen. In this way, we can easily find formal charge of any atom present in a molecule based on the given formula. This is the formula which is used to find about the formal charge.